All right, in this video, we're going to look at two different problems from our packet. First thing we're going to look at is on page 3 in your packets, in the 8B packet. And if you could also be taking your calculator out as well. So we've got the decay of an element is represented in the table below. The sample starts with 2 grams, and that is decaying over time. So we're going to start out by graphing this. So we'll draw in our x and y axis. On our x-axis, we have hours, and we have our mass in grams on the y-axis. Notice the largest is 2, so we got to make sure we can get up to 2. So maybe we'll go by 0.25s. 0.25, 0.5, 0.75, and 1. 1.25, 1.5, 1.75, and 2. And then down on the x-axis, we'll just go by 1s. We've got to get up to 6. So we've got 0, 2, 1, 1.74, 2, 1.52, and we'll keep going just plotting each of those. So from the graph, it appears to not be linear. It's got some curve to it, so it appears to be exponential. So down in part 2, we want a model, so we need to think y equals a times b to the x. So we're going to have y equals, our starting amount was 2, and to figure out our b value, let's do a successive ratio. So we've got to do y2 divided by y1 for our successive ratio. So that would be 1.74 divided by 2, and that's going to give us 0.87. That seems to make sense because it is decaying, so it should be something less than 1. So we'll put the 0.87 in for b. And we need to make sure we tell what x and y represent right with our equation. So x was our hours, y was our mass in grams. So for our domain and range, well, time could keep going on. So our domain, we could have x is greater than or equal to 0. And for the range, the highest we ever get is 2. And we do equal to. But in an exponential function, it'll get closer and closer to 0, but it will never hit. So our lower bound is 0, and we're not including that. So up next, we want to find the mass after 11 hours. Hours was our x value. So we'll have y equals 2 times 0.87 to the 11th. And take a moment to punch that in, see what you get to the nearest hundredth, and make sure to put your label on your answer. So we should have gotten 0.43, and it was a y value we found, so it was grams. Next up, we want to know when will the mass be 0.5 grams? Well, mass was a y value. So we'll have 0.5 equals 2 times 0.87 raised to the x. We've got to divide by 2. That'll give us 0.25 equals 0.87 to the x. And if you want to find an x in the exponent, we've got to do a log. So we're going to have log base 0.87 of 0.25 is equal to x. And we'll give you a moment to sub that in. And notice we're rounding to the nearest hundredth. And we should get to the nearest hundredth. The x is 9.95, and our label on that should be hours. And in 6, we want to find the rate of change at 7 hours. We're going to round to the nearest hundredth, and we have to have units. So rate of change, the word that should pop in our head is slope. We want to do it at 7 hours, so we're doing 7 and 7.01. Take a moment to punch those into your graphing calculator. In the equation, the y equals 2 times 0.87 to the x, and see what you get for our y values. So for 7, we should have gotten 0.7545 and change. For 7.01, we should have got 0.7534 and change. Now we'll do our change in y over change in x. So we're going to do 0.7534 and some other stuff, minus 0.7545 and some other stuff, over 7.01 minus 7. So when you put that in your calculator, do the control divide first, then scroll up and select each of those things you want. When you scroll up and they're highlighted, hit enter to bring them down. You'll want to do that for the ones in the numerator so you have all the decimals. And then you can just punch in the 7.01 minus 7. And we're going to round to the nearest hundredth. So we'll give you a moment to put those in, hit enter, round to the nearest hundredth, see what you get, and see if you can put a label on your answer as well. So when we put that in, we should get negative 0.11. A rate's units are always something per something. You drive at a rate of miles per hour, so it's always your y units per your x units. Our y units was grams per, and our time unit here was hour. Grams per hour. You can do G/HR, that would be fine as well. So this problem included lots of different things that we have worked with. Finding an x, finding a y, finding a rate using our 0.01s. We're going to move over to page 4 now. So in this question, we have a lot of different questions embedded with it. So we're going to number them as we go. The original price of the jacket was $120. The price of the jacket is reduced by 10% each week till the jacket is sold. Assuming no one buys it earlier, when will the price of the jacket be $60? So that's our first question we have to answer. When will the price of the jacket be $60? Second one, we want to know when will it be $50? How long will it take for the price of the jacket to decrease to $1? There's the third question we need to answer. When is the price of the jacket decreasing most rapidly? That's our fourth question. Fifth question, if the original price of the jacket was $80, how would your graph, table, or equation change? And the sixth question, if the weekly discount were 15%, how would your graph, table, or equation change? So as we're doing this, you can either do it on a separate sheet of paper or you have some space up on the top or the bottom to work with this. So first off, let's find an equation. We're starting with 120 and we're dropping 10% each week. So that's 100% minus 10%, which would give us 90%. Move your decimal over 2, and that gives you 0.90. So we're going to have y equals our original price of 120 times 0.90 raised to the x. We should always tell what x and y represent. X, in this case, is weeks. And y, in this case, is our price. So for the first question, when will the jacket be $60? So we want to put 60 in for y. And we need to solve for x. So we'll divide by 120. And that's going to give us a half is equal to 0.90 to the x. And you could just do 0.9 to the x if you want. We're solving for x in the exponent, so we need to do a log. So we're going to do log. A base of the log is the same as the base of the exponent. So 0.90. Inside of the log is the half, and then it's going to equal x. When we put that in, we get x is equal to 6.57. Well, let's think about this scenario. So it's reduced after each week. So it's reduced like at the whole number of weeks, essentially. It's reduced when x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4, and so on. So if the price we're looking for is not at a whole number, it can't be that price until the next week when it's reduced. We don't have partial weeks that we're working with. So if we get 6.57, it wasn't low enough at week 6, so that means it will not be low enough again till week 7. So you've got to see what's going on in your scenario, and a lot of times that'll tell you what you should work with. So let's have you take a second and do the second question on your own. So again, see if you can do the one for $50 and solve for x. So we should have gotten that x was equal to 8.31. So if it didn't happen in the 8th week for us, it wouldn't happen until the 9th week. So week 9 is the first time the price would be at $50. It's not going to be exactly 50, but that's the first time it's going to drop below 50. So question 3 is a similar idea. Just we're doing it for $1. So we'll do that one together. We'll have 1 equals 120 times 0.9 to the x. Divide by 120. So we're going to have x equals log base 0.9 of 1/120th. And when we put that in, we're going to get x equals 45.44. So again, if it didn't happen in the 45th week, it won't happen again until the 46th week. So we'll have week 46. And the reason for that, sometimes things don't happen at the in-between values. They're dropping the price each week. It's not being continually dropped throughout the week. So for number 4 now, when is it decreasing most rapidly? Well, let's draw a sketch of an exponential decay graph. So we have something like that. So we want to know when's the biggest drop. Well, the biggest drop is at the start. And the reason for that, when your price is at 120, that's when 10% is the biggest drop. That's a $12 drop if you drop 10% at 120. But as time goes on, 10% of your price is no longer as big of a drop. So that's why at the start is the biggest drop. If the original is 80, what are some things that would change? Well, in the equation, instead of 120, we would have 80. And also, if this is our original here, let's say, if we're at 80, that y-intercept is now not as big. Because that y-intercept is not as big, that initial drop is now not as big. So we've got our equation, and that y-intercept is changing. What would happen if it's a 15% drop? Well, if you do 100% minus 15%, that's going to give us 85%. And we're going back assuming we're at the original 120 again. So we'll have 120 times 0.85 to the x would be our equation. Now, in terms of a graph, what we would notice, that y-intercept is going to be the same. So if that was our original one, the y-intercept is going to be the same for this new one, but that drop should be steeper. Because if you're taking 15% off, the price is going to be dropping at a much quicker rate and getting down low more quickly. That's it for this video. Have a great rest of your day.